Yeah, so here's another simulation exercise. We are going to try to control an intersection with traffic light and pedestrian crossing and so on. So if we're going to have a look here, in the simulator is a simulator that's simulating a traffic light or an intersection. And you should program this, and here it's indicated maybe we have feedback if the light bulbs are intact. Maybe that is current flowing through them. These are probably lead or something. There's a fault indication on the bulbs. So maybe you should make a small program controlling this light. This is an example down for programming this, but what you are going to program is this one. Make an instance, call it here, call the main, and test it. Maybe we should go down to look at the intersection here. Quick. Here. So here is this. This is the model. You can activate intersection fault. And then you get output from a model that there's a fault in the intersection. Maybe you should do do something with it in program. And here is pedestrian access, these here. So access to the intersection. There is a small light here. Maybe I could zoom into. There's a small indication here, which is an output that turns yellow if you ask for access, but you have to wait until they stop the traffic here. So then with this one, you could, is yellow, you should switch it on. There is a light indicating to the pedestrian that, okay, you have to wait, but we have accepted your request, so maybe you will get a green light, or your program should let them have a green light. Here, this one in the middle, that's green light in both directions simultaneous. You will get this symbol. It's not too bad. And here's cars. The detectors in the street here that there's cars in the intersection too. Yes, and these they change colors. So you can switch them on and switch them off. This is just a push button. You push it and you ask for access to. And then the green and the lights, you should make them flash. Maybe the pedestrian should flash green, run, get over the intersection, or someone is going to run you over. And here too. And it's a little too here to when talk about how lights are working. If you're looking in Norway, maybe in fault condition, you should have a flashing yellow. In this template project, in the system block, there are fast flashing outputs that you could use in your program. Just use this as an input to your program. And I think stopping is green and then yellow and red, and start is red, yellow, and then green. That's the way we do. And this is just to indicate from where is this yellow coming. If it's a yellow, that you have to stop, and if it's red and yellow, you can prepare to start. It's just to indicate where it came from. Of course, we could have a green and yellow to say, okay, as from running traffic, and now it's stopping. But of course, mentally, we couldn't do that, because this green light could be a dime size or something like that, and people would see it, and the red one could be a pancake, and people wouldn't see it. And if you have a green and yellow at the same time, they say, okay, it's green. We are going to do it right. Okay. Now we have to go back. We can go back up here for exercise, and here's the assignment. Advanced final state machine. Use the PLC IO tags, TIA portal, and so on. Control. We call it FB intersection control. You call it whatever you want, and you call it in main and program main. Make sure that's tied into the task, this cycling task. And what you need is your PC with a PLC simulator, and get a couple of screens too, at least 2 screens if you're going to do any serious programming here. Yes, the program function block, blah, 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 blah. 3 program tips at the bottom. Make instance and so on interconnected, so it looks like this. And here is just a snag from the tag table, inputs and outputs. Suggestion, and here is how you could call it in this program exercise main if you want to. Yeah, and here is some tips. No green lights simultaneous. No light sequence is what we talked a little about. Switch to that direction. Start in both directions. Control cycle traffic through the intersection. And you use parameters for how long. If you have a main road, maybe you should be green for a little longer time because there's more traffic, and crossing traffic, you should just allow half a car to pass. I don't know how you should probably use parameters too on this. The light bulb intersection go to fault state. Or a light bulb fault. A light bulb fault, you try to switch on a light bulb, but you don't get a feedback that the bulb is on. I think the fault here works on the green and the red, and not the yellow. We said the yellow is always okay, or we don't detect anything on the yellow. The red and the green, they are important, especially the red is important. Because if it's switched to flashing on the fault flashing green, yellow in both directions, and if it doesn't work, of course you have signs, yield signs in your intersection that then control the traffic. I think it's police first, then it's lights, and then it's signs. I think that's the hierarchy of how this should be controlled. And police controlling the traffic, I haven't seen one yet, and I'm pretty old. There should be no pedestrian crossing, pedestrian green along this interfering traffic. Of course, square wave pulses, you can get it out of this IDB sys data block. YS1 is fast flashing and the other one is flashing. Use to flash the lights. You can program a flashing system in your program too if you want to, but they are available in this template project. Download and test. And tested using the feed single item. That's not correct. I'm going to remember to correct this because this is from the last exercise, another exercise. So it's just the intersection is, you don't have to enable the intersection, is enabled. Light bulb function block. We're going to look at that. In here is 6 times for each of the bulbs. Well, whatever. So here is that light bulb control. So how this is control. Switch on. Yeah, that's command switch on. Current flow through bulb is on. So that's the feedback you get into your programs, because this is a sub program, and you get a control on here to switch on, get a control on, and you get a fault if you don't get the feedback. So this is basically also could be a state machine. Here is an interface that you can use. That's quite a bit here, so we just read through it. And here too, they are available for HMI display, and here we enable the intersection. We switch it off. Switch off the intersection control for me. I don't know, maybe it then should flash yellow in both directions. And the pedestrians, they lights are just off. So the pedestrians, they have to cross at their own peril. But that's just the way it is. Run fast. Yeah. And so here is this, the 6, there's more than, how many instances? 1, 2, 3, 4, 5, 6, 7, 8, and 9 instances. But here is one instance for each traffic light. I think we suggested 6 instances of those. And here is the time, and we should probably have something for the static here, a state for the intersection, the next state. If you do some detection, the next step is traffic, but then you have to do some cycling in your program. Maybe you need more. Here we have opened up for 10 timers. So this the long timing system that we have in here, you can call a function, get this long time out. There's another way of doing this too. So here's the IO tags. Found, documentation, light listing, this FB traffic light control. If you want to make your own one, there is a suggestion down here in information. So here is the interface. You can copy this interface into a text file, import it into TI portal, compile it, and then the interface should be ready. There might be not, let's see, external write or visible. There might be enough meta information here to be able to make an HMI out of this. The constants, Yes, and there's no code in here because that's what you want to write. And here is this light bulb function block. Could work something like this. It is a little documented here too, so you could use this one. And here's not a state machine, but it's timing in here to check if this light is being switched on. We don't care too much if the light switches off. We should probably care a little about the green light not going out. But whatever. If you can extend this and do whatever you want. That was the simulator. Switch on. And here there was light bulbs 3, 6, 9, 12. So it's probably 12, not 6 instances we need in our function. Here is some time and state that you could register. How long have the traffic been on here? How long has the intersection been fault? Enable the program. There's a fault in the intersection. Reset the program if you need a reset. I think maybe when you have a fault input to your program, maybe you should say, okay, the fault disappears, but we are not going to start the traffic, or we have a fault in the bulb. You have to reset the program, and then maybe you should go to red state, stop traffic in both directions, and then start traffic in, maybe you have a priority direction, a parameter for that in your program. Yes, and here is something. Here you can force all the lights off, the arrows on the lights, then you won't get this feedback for the light. I think it's for red and the green only, pedestrian and cars. So that's how you can operate too. So you can fault the lights here, and here it's an intersection fault that it might be a common fault, no matter. There's some fault in the intersection. So we just have a common fault. Yeah. And here is the simulator that you have in here, the program. Here that uses arrays for inputs, because there's a lot of arrays. We've got a hairbrush with inputs and outputs, a lot of inputs and outputs and terminals. So we use an array and for the input, and then we use just indication for the lights: red, green, yellow. And here detectors, detector 1, 1, 2, and so on. Because these constants here, there's one for each of the lights too, and they can be red, green, yellow. It's kind of nice to use constants too, because then we can switch the lights on simultaneously in the program, whatever. So this is how this is programmed. Of course, you can look at this and how the interface to the simulator is in this template project. And here is something too that you can copy into your program. Be a little careful if you copy directly in here. It might be, it says that all these tags, they are illegal, but they should be legal. And here is this flashing that you could just input, external input, fast flashing, or let's call it whatever, but external F, you can't use that. So section control. So if you make an intersection control with the interface that suggests that you have imported, this code should work and connect your program to this IO here. And this exercise mine, of course, has to be called in this your program main and linked into a task. So that was again intersection control. So yes, it is not as complicated to write this, because there's a lot of copying of code in here. There's certain ways to do it. So what we have done and has suggested it that we have a subfunction controlling a bulb, because the model, you can fail the bulbs, not the yellow one, but the red and green one, you can fail those. And then you should react on that and maybe switch the intersection idle state flashing orange in both directions or something. Yes, there were some typing errors in here, but I'm going to fix those if I can find them. Yeah, I think that was pretty much what this is going to be about. It's not that easy to make this program, but it's not that hard either. State machine, don't try to solve a control like this using memory elements like set, reset, flip-flops. Then we're definitely going to kill someone in the intersection with green light simultaneously on and so on while you are testing this. In a state machine, the intersection can be in one state at the time maybe traffic east, west, or north, south, or whatever you call it, direction 1, direction 2, or whatever you call it. And just control the lights. Maybe you could control the outputs and say, okay, these outputs we make temporary for the outputs, so we just control the outputs, light outputs in every state to make sure in this state, this is the light combination, hard-coded in the state with your code, so you are pretty certain that's what it is. What you should do is you should use internal memory and then write to the outputs or control the lights later on. But it's a little up to you. Programming, you can do program a lot of ways, but it should be robust, as robust as possible.